Light is fast enough to circle the entire Earth 7.5 times in a single second, faster than you can even finish reading this sentence out loud. It crosses the distance between you and the screen you are watching this on so quickly that your brain treats it as instantaneous, as if cause and effect happen at exactly the same moment. But here is the unsettling part. That number, roughly 186,000 miles every second, is not a law carved into the fabric of reality the way you think it is. It is just the value we happen to live with, a number nature could have picked differently, and one that quietly decides whether stars ignite, whether atoms hold together, and whether a species like us ever gets the chance to stand around and ask questions about it at all. So what if it were not 186,000 miles per second? What if the speed of light was slower? Not a little slower. Slow enough to break your brain. Today we are going to take the single most important number in physics and dial it down, stage by stage, from barely noticeable to utterly reality-shattering, until the entire universe stops making sense. By the end of this, you will never look at sunlight, your own reflection, or the night sky the same way again. Let's start with what light speed actually is, because most people think of it as a speed limit for light bulbs and lasers. It is not. The speed of light, roughly 300,000 kilometers per second, is the speed limit for causality itself. It is the maximum rate at which one event in the universe can influence another. Albert Einstein figured this out in 1905, and it became the spine of special relativity. Every equation about mass, energy, time, and space has this number baked into it. E equals mc squared is not just about energy. That c is doing enormous work in that formula, because it is squared, meaning even a small chunk of mass converts into a staggering amount of energy specifically because light moves so absurdly fast. Sunlight left the sun 8 minutes and 20 seconds ago by the time it hits your skin right now, which means every single sunburn you have ever gotten was caused by light older than your last conversation. Every time you check your phone's GPS location, satellites are timing signals down to billionths of a second, using this constant to make sure your map does not send you into a lake. Global positioning only works because engineers accounted for the fact that time itself runs slightly differently on a satellite moving at orbital speed than it does down here on the surface, and every one of those corrections traces back to this single constant. Light speed is not a detail. It is the scaffolding time and space are built on. It shows up in how stars burn, how atoms hold themselves together, how gravity propagates, and even how quickly a falling apple starts to feel the pull of the Earth beneath it. Physicists sometimes describe it as the universe's ultimate speed limit sign. Except there are no exceptions, no back roads, no carpool lane, and no talking your way out of the ticket, not for light, not for gravity, and not for you. So now let's start bending that scaffolding, one snapped rule at a time. Picture the speed of light dropping from 300,000 kilometers per second down to just 300 kilometers per second. That is roughly the cruising speed of a commercial jet. It sounds almost survivable, right? It is not. The moment you turn on a lamp, the light does not fill the room instantly anymore. It crawls outward like a slow-motion wave, and you would watch your own room light up in visible stages, corner by corner, the way a flood spreads across a floor. Now think about your eyes. Your eyes work by catching photons that bounce off objects and slam into your retina. If light crawls at jet speed, the image reaching your eyes is not you looking at the present. You are looking at the very recent past, smeared out and delayed depending on distance. Look at a friend standing 10 meters away, and you are seeing them as they were a tiny fraction of a second ago. Look across a stadium, and the delay becomes visible, almost like a broadcast lag between different sections of the crowd. The wave of a hand reaching row 10 before it reaches row 200. If this kind of universe-bending scenario is your thing, hit subscribe now, because we are about to leave commercial jet speed completely behind and head somewhere far more disorienting. Airports would become nightmares, because radar and landing lights would no longer represent the true position of anything moving faster than a jetliner. A pilot watching another aircraft's lights would essentially be watching a rerun, not a live feed. And at those closing speeds, a rerun is exactly what gets people killed. And there is a darker complication here that most people don't consider. Every camera, every fiber optic cable, every wireless signal on Earth depends on light speed limits for synchronization. Slow that constant down to airplane speed, And modern communication does not just glitch. It essentially stops functioning because the timing assumptions baked into every microchip on the planet become instantly wrong. Banks, stock exchanges, and power grids that rely on synchronized clocks across continents would desynchronize within seconds, and the ripple of failures would spread outward slower than the failures themselves, meaning parts of the planet would be operating on outdated information about other parts of the planet, a kind of civilizational jet lag baked directly into physics. Let's drop it further. What if light moved at the speed of sound, around 343 meters per second? Now things get genuinely dangerous. Remember sonic booms, that violent shockwave when a jet breaks the sound barrier? At this new light speed, anything that moves faster than a jet would create a light boom, a burst of compressed, overlapping wavefronts slamming into whatever lies ahead of it all at once instead of arriving smoothly over time. Imagine a race car breaking its own light barrier, outrunning the photons bouncing off its own body. For a fraction of a second, the car's own reflected light cannot keep up with the car itself, meaning an observer positioned correctly would see the vehicle appear to vanish and then reappear, its own image lagging behind it like a ghost trying to catch up. Fighter jets would leave visible shockwaves of light distortion instead of sound, rippling the air like heat haze but far more violent. A cone of compressed brightness trailing behind every supersonic aircraft. Meteors entering the atmosphere, already brutal at normal light speed, would now create blinding compressed flashes because the light generated by their friction cannot escape the collapsing wavefront around them fast enough, essentially stacking photons into a single overwhelming pulse instead of spreading them out smoothly across the sky. Lightning would become almost impossible to watch safely because the flash and the light boom created by the bolt's own violent motion through the air would arrive as one compressed, blinding event instead of the brief flicker we know today. Even something as simple as a spinning ceiling fan would start doing strange things to the light around it, chopping and dragging illumination in visible smears with every rotation. And this is where the science stops being fun and starts being existential. Because at this speed, ordinary chemistry starts breaking. The electromagnetic force that holds atoms together, the very same force responsible for light, is mediated by particles that cannot travel faster than light. Slow light down to sound speed, and you slow down the electromagnetic interactions binding your own body's molecules together. Nerve signals, which rely partly on electrical processes governed by this same speed limit, would begin lagging. Your thoughts, quite literally, would take longer to become actions. Now let's go slower still. What if the speed of light dropped to the speed of a car on the highway, about 30 meters per second? At this stage, we are not talking about inconvenience anymore. We are talking about a total redesign of biological life. Photosynthesis, the process every plant on Earth uses to convert sunlight into usable energy, depends on photons striking chlorophyll molecules and triggering nearly instantaneous electron transport chains. Slow photons down to highway speed, and that near-instant reaction becomes a crawling, inefficient process, because the energy delivery itself is now bottlenecked by how fast light can even arrive and interact at the molecular scale. Even a photon that does eventually strike a leaf would deliver its energy so gradually that the plant's own internal chemistry might dissipate the charge as heat before it can be captured and stored, turning what should be fuel into wasted warmth. Entire ecosystems built on rapid solar energy conversion would starve, crops wilting not from lack of sunlight but from sunlight that simply cannot deliver its energy fast enough to be useful. Meanwhile, the fine structure constant, a number physicists use to describe how strongly light and matter interact, is directly tied to the speed of light in its equation. Change light speed and you change how tightly electrons are bound to atomic nuclei. At car speed, chemical bonds as we know them would likely become unstable. Carbon, the backbone element of every living thing on this planet, might not bond the same way at all, and the specific geometry that lets carbon form 4 stable bonds, the geometry behind every strand of DNA, every protein, every cell membrane on Earth, could shift into configurations chemists have never observed in nature. This is not simply a slower version of our universe. It is potentially a universe where the chemistry that builds DNA cannot exist in a recognizable form, where the very idea of a stable, information-carrying molecule capable of reproducing itself might quietly become impossible. Before we go slower still, Consider what this does to something as simple as a gunshot. At normal light speed, the muzzle flash and the bullet's impact appear to happen almost simultaneously to any nearby observer, because light so drastically outpaces the bullet itself. At highway speed light, a bullet fired from a rifle would actually outrun its own muzzle flash, meaning the visual evidence of the shot would arrive at a target after the bullet that caused it. Soldiers would see impacts before they saw the corresponding flashes, a completely inverted cause and effect relationship for anyone trying to react to gunfire. Entire strategies of warfare, built for centuries around what a soldier can see and how quickly they can react to it, would collapse overnight, because the assumption that light informs you of danger before the danger physically arrives would simply stop being true. Radar, laser rangefinders, and every targeting system relying on light-speed reflection would become unreliable at exactly the ranges where accuracy matters most, forcing militaries back towards sound, vibration, and raw instinct. Technologies and instincts humanity largely abandoned once radar made them obsolete generations ago. Let's go even further, because now we arrive at something genuinely mind-bending. What if light moved as slow as a human walking, about 1.5 meters per second? At this point, causality itself becomes something you can watch happen in front of you. Turn on a flashlight and you would visibly see the beam extend outward across the room, like pouring light instead of switching it on. Clap your hands, and you would see the visual evidence of the clap ripple outward from your hands before your eyes even process the sound. Actually, you would see two separate delayed events: the light of the motion and the light bouncing off the sound waves disturbing dust in the air, arriving at wildly different times. Now think about the sun. If light moves at walking pace, sunlight would take not 8 minutes, but potentially years or centuries to physically cross the 93 million miles from the sun to Earth, depending on exactly how we are scaling the constant. If we are talking true meters per second slowdown, sunlight would essentially never arrive within a human lifetime. Earth would be plunged into permanent darkness, because the very mechanism carrying solar energy across space now takes longer than civilizations survive. No slow-crawling photons reach us in time to power anything, not solar panels, not greenhouses, not a single leaf reaching toward a sky that has nothing left to give it. Photosynthesis stops entirely. The surface of our planet freezes, oceans locking into ice from the poles inward, and within a few centuries every visible trace of the warm, sunlit world we know would be buried under kilometers of frost. Any surviving humans, and it is a genuine stretch to imagine there would be any, would be forced underground, clustered around geothermal vents and nuclear reactors, generating their own artificial light from processes that do not depend on photons crossing open space. Farming would move entirely indoors under artificial lamps powered by fission, because the one thing a slow-light universe cannot offer is a reliable outdoor sun. Entire generations would grow up never having seen true daylight, telling stories about a warm yellow disk in the sky the way we tell stories about mythical creatures, a memory passed down rather than a daily experience. Civilization would essentially retreat into a permanent cave, lit entirely by fire and electricity, because the sky above would offer nothing but cold and black forever, or at least for longer than anyone alive would ever live to see change. This is the first truly existential turn in our story, because at this stage, slowing down light does not create a stranger version of Earth. It creates a dead one. But let's push past dead Earth and ask the real cosmic question, because the true horror and wonder of this thought experiment lives at galactic scale. Right now, light from the sun takes about 8 minutes to reach us. Light from the nearest star beyond our sun, Proxima Centauri, takes about 4 years, and light from the center of our galaxy takes around 26,000 years. Every time astronomers look into deep space, they are looking into the past, sometimes billions of years into the past, because that is how long the light took to cross the void. Now imagine slowing light down by even a modest factor, say cutting it to 1/10 its actual speed. Suddenly the observable universe, everything we can currently see and study, shrinks dramatically, because in a slower light universe, less time has been available for that light to reach any given point since the beginning of everything. Entire galaxies currently visible to our telescopes would be permanently hidden beyond a much closer cosmic horizon. We would be blind to enormous stretches of existing reality. not because those galaxies do not exist, but because their light simply has not had enough time to physically travel far enough to ever reach us. This actually connects to something astronomers already grapple with today called the Fermi paradox, the puzzling silence of the universe, despite its enormous size and age. Slash the speed of light, and you slash the size of the observable neighborhood any civilization could ever detect another one within, meaning countless intelligent species could exist scattered across a slow-light cosmos and never have even the theoretical possibility of noticing each other, sealed away behind horizons that no signal could ever cross in time. Two civilizations could be neighbors in every meaningful sense, separated by a distance that would be trivial at our universe's actual light speed, and still remain permanently, mathematically unaware that the other one ever existed. And there is an even deeper problem buried in all of this, one that touches the birth of the universe itself. The rate at which the early universe could expand, cool, and allow particles to interact was fundamentally shaped by the speed of light. Immediately after the Big Bang, the universe went through cosmic inflation, an incomprehensibly rapid expansion, followed by a slower cooling period that allowed protons, neutrons, and eventually atoms to form. This cooling had to happen at a very specific pace, because if the universe cooled too quickly or too slowly relative to how fast particles could exchange information and settle into stable configurations, the resulting mix of matter would look completely different from the one that actually surrounds us. Nuclear fusion inside forming stars depends on particles overcoming electromagnetic repulsion, a process again governed by the same physical constants tied to light speed. If light had been dramatically slower from the very beginning of time, stars might never have ignited the way they did. Fusion reactions inside stellar cores rely on an extremely delicate balance between gravity crushing matter inward and electromagnetic and nuclear forces pushing back outward. Shift the speed of light, and you shift that balance. Some physicists who study variable speed of light theories, an actual fringe but seriously examined area of cosmology championed in different forms by researchers like Joe Magajo, argue that a permanently slower light speed early in the universe's history could have prevented stars from forming at all, leaving the cosmos as an eternal dark soup of gas and dust, never igniting into the blazing furnaces that eventually cooked up every heavy element in your body. No carbon, no oxygen, no iron, none of the elements forged inside dying stars and blasted across space by supernovae, because none of the stars ever lit up in the first place. Every atom heavier than hydrogen and helium in your body, the calcium in your bones, the iron in your blood, the oxygen you just breathed in, exists only because stars burned bright and violently died. Slow the light down enough at the dawn of time, and that entire chain of stellar cooking never starts. Now let's reach the true climax of this thought experiment, the most extreme version imaginable. Picture an entire universe where light has always moved barely faster than a snail, a universe that has existed for the same 14 billion years ours has, but where causality itself crawls at a pace slower than continental drift. In this universe, galaxies as we understand them likely never assembled, because gravity's influence, while not directly limited by light speed in the same way electromagnetic radiation is, still operates within a cosmic framework where matter, energy, and information exchange are throttled by this same fundamental constant. Vast clouds of primordial hydrogen and helium, the raw material every galaxy is built from, would drift for eons without ever receiving the kind of rapid feedback and energy exchange needed to collapse into coherent spiral or elliptical shapes, remaining instead as diffuse, barely structured fog stretched across unimaginable distances. Black holes, if they could even form, would behave almost unrecognizably, because the physics of their event horizons, their Hawking radiation, and their gravitational interactions with surrounding matter are deeply entangled with the speed of light in ways theoretical physicists like Stephen Hawking and Kip Thorne spent careers mapping out. A slower speed of light rewrites the maximum density gravity can achieve before forming these cosmic monsters, shrinking or bloating the threshold at which a collapsing star tips over into an inescapable gravitational well. Entire categories of extreme astrophysical objects might simply never exist in a form we would recognize. Neutron stars, those city-sized remnants, so dense a single teaspoon would weigh billions of tons, depend on a similarly delicate interplay between gravity and the forces holding matter apart, forces that are themselves shaped by how fast information about that force can propagate. Change the constant, and you change whether those remnants stabilize at all or simply keep collapsing straight into black holes, skipping an entire category of exotic object that currently exists in our sky, pulsars included. Those lighthouse-like stellar corpses whose predictable radio flashes have helped astronomers test relativity itself for decades. This is a universe potentially incapable of building the very structures, stars, galaxies, black holes, neutron stars, that make our own universe as dramatic and life-permitting as it is. And here is the truly unsettling twist. Even if somehow, against overwhelming odds, life managed to spark in this slow-light universe, it would experience reality in a way almost impossible for us to imagine. If nerve impulses, chemical reactions, and every information exchange in a living body are ultimately bounded by how fast electromagnetic interactions can occur, then thought itself would crawl. A creature in this universe might take what feels to us like hours to process a single visual stimulus. Communication between two individuals standing near each other might involve waiting minutes for a spoken word's meaning to fully arrive and register. An entire conversation stretched out over what would feel to us like an agonizingly slow negotiation. Predators and prey would exist in a strange truce, because a chase in the traditional sense might be physically impossible if every nervous system involved is bottlenecked by the same sluggish electromagnetic signaling. Reaction time as a survival trait might not even exist as a concept, replaced instead by something closer to prediction. Organisms evolving not to respond quickly, but to anticipate outcomes far in advance because responding in the moment is simply too slow to matter. Evolution itself, which depends on biochemical processes happening fast enough to sustain complex multicellular organisms, might never produce anything more complex than extremely patient, extremely slow-thinking single-celled life, if it produces anything capable of what we would call life at all. And if somehow intelligence did emerge in such a universe, the very concept of urgency, of danger, of excitement, might not translate into anything we would recognize as emotion, because emotion as we experience it is tightly wound around how quickly our bodies can detect and respond to the world around us. Fear itself, that split-second jolt that saves you from stepping in front of a car, might simply have no evolutionary reason to exist in a universe where nothing ever truly arrives quickly enough to require it. There is one more twist worth sitting with before we zoom back out, because slowing the speed of light does not just change how fast light travels. It changes how close ordinary speeds get to that limit, and that is where relativity stops being an abstract equation and starts becoming an everyday experience. Time dilation, the effect where a moving object experiences time more slowly relative to a stationary observer, is normally something you would need a particle accelerator or an orbiting satellite to notice, because you have to be moving at a meaningful fraction of light speed for the effect to matter. But if light only moves at walking pace, then walking pace is now a meaningful fraction of light speed. Simply going for a jog would measurably slow your personal experience of time compared to a friend sitting on a bench. Driving to the grocery store would age you detectably less than staying home. Airplanes would become genuine time machines, their passengers landing measurably younger than the people who stayed on the ground, not by microseconds hidden in atomic clocks, the way it works in our real universe, but by minutes or hours, openly noticeable without any special equipment at all. Twins separated by nothing more dramatic than one taking a bicycle ride around the block could return home to find they have drifted out of sync with each other. A version of the classic twin paradox playing out on ordinary street corners instead of in spacecraft. Marathon runners would finish races technically younger than the spectators who stood still and watched them cross the line. A strange trophy no one could actually perceive without careful measurement. Every commute, every stroll, every sprint for a bus would come with a tiny cumulative cost or gain in how much of your own life you actually get to experience, and no one would ever be entirely sure, without checking a clock, exactly how much time had passed for anyone else. So step back from the extremes for a moment, because there is something worth sitting with here. The speed of light being exactly what it is, fast enough that sunlight reaches us in minutes rather than centuries. Fast enough that your nerves fire quickly enough to pull your hand off a hot stove, fast enough that stars can ignite and galaxies can assemble is not a convenience. It is the precise, narrow condition that allowed atoms to bond, stars to burn, planets to form, and eventually, incredibly, for a species like us to stand on a rock and ask what if it were different. Every thought you have ever had, every heartbeat, every sunrise you have watched happened within a universe fine-tuned around a number most of us never think twice about. Slow that number down even slightly, and none of this exists. Not the stars, not the chemistry, not the thought experiment you are listening to right now. Scientists have a name for this kind of unsettling coincidence: the anthropic principle, the observation that the physical constants of our universe seem oddly well-suited to producing observers capable of noticing them. It does not explain why the constants are what they are, but it does highlight just how many independent dials, light speed among the most important of them, all had to land in exactly the right position for anyone to ever exist and ask the question in the first place. Maybe that is the real takeaway. We spend so much time imagining alien worlds and distant galaxies as the exotic frontier of what if, when the truest what if was sitting inside a single physical constant the entire time, quietly making everything else possible. The universe did not have to allow light this particular speed. It could have been slower by a single percent and still, over billions of years, cascaded into a radically different set of stars, a radically different periodic table, a radically different chance at chemistry complex enough to think. And yet here we are, built entirely out of the consequences of that number, 300,000 kilometers every second, quietly running underneath every experience you will ever have. So the next time you flip on a light switch, or watch a sunset, or catch your own reflection in a window without a moment's delay, remember that you are witnessing one of the most improbable, most fragile pieces of cosmic luck in existence. Nothing about your ability to see that light instantly was guaranteed. Nothing about the stars finishing their multi-billion-year furnace work in time to make the atoms in your body was guaranteed either. What if that luck had gone differently? We may never know for certain, but somewhere out there, in the vast mathematical space of possible universes physicists love to speculate about, there might be one where the lights are still crawling toward their first star, patiently, endlessly, in a darkness that has not yet had the time to end. But that is a story for another What If.